Hello everyone, this is Joe Talks here. I just wanted to do a quick follow-up video to a previous video I had done where I performed an unboxing and a quick review of the BYGD 800W power inverter. So if you happen to watch that video, you probably saw where I had hooked the inverter up and ran it at a full load around 650 to 700 watts using a heat gun. And when I did that, the original cables that came with the unit got really hot to the touch. So one of the things I noticed is that the crimp is kind of loose, or not really loose, but it just feels kind of flimsy, like it's not really tight. And so I wanted to explore some other options that I could use instead of using these standard OEM cables. And so I decided to try using some automotive jumper cables. And so before I ordered these, I went in and measured the original size of these cables, and they measure out to be about a 6-gauge wire. And so the way that I determined that was I went in and I stripped back some of the wire and I measured the diameter, and then I compared it to a website that I found online where you can plug in different wire sizes and it will tell you what the diameter is. So this measured out to be about 170 thousandths, and according to this website, the diameter of 6-gauge wire is about 162 thousandths. So I believe these to be 6-gauge wire. Now, one other thing I wanted to do was just verify that the 6-gauge wire was going to be adequate for the application that I was going to use. So I also went and found another website where you can plug in various voltages and wattages, and it will calculate the amount of amps that is going to be drawn through these wires. So I went to another website on rigidtables.com, and I plugged in for DC current, since we're running a 12-volt DC battery, and I put in 800 watts, even though I really doubt I'll ever be using this at the full 800 watts, but we'll assume max conditions. And then I also put in for 12 volts, and I calculated that out, and so at the maximum power this is going to be drawing 66 amps. So if we look at a 6-gauge wire with copper wire with a good insulation, which this has really thick insulation on it, it should be capable of drawing or of handling up to 75 amps. So I think for my application, I'm probably pushing the extreme of what this wire could do, but I think I'm okay. So with all that being said, let's go ahead and hook it up, and I will demonstrate running this the same way I did in the previous video, and we'll just verify and see if these cables do in fact get hot. So I'll go ahead and hook up the power and hook up the negative, or hook up the red side and then hook up the negative. We'll turn it on. Okay, so we got good power to the inverter. We'll get my heat gun, plug it in, and then I'll just run this on the low side since that was adequate to generate the heat. So right now I'm pulling about 630 watts. So I'll just let this run for a few moments. So if I touch the copper itself, it is getting a little warm, but I would expect that just being a clamp-on electrical connection. It's going to have a little resistance in that joint. And so this is issuing a low voltage alarm, so my battery may not be charged up completely. But we'll draw enough power through it to at least see if these are getting warm. So there, I've been running them for about 30 seconds to a minute, and these are not getting anywhere nearly as warm as those other connectors were. And cable's not getting hot. I did go with a lot longer cable just so I could get to a battery that's further away. They're not getting warm at all. Okay. So I think using these jumper cables are going to work a lot better than those original cables do. So I will put links down below to the cables that I used. Those will be affiliate links. And again, if this video helped you at all, please subscribe to my channel and like this video. And it does help us out. So, all right. Thank you.